So now we're going to build on our logical reasoning skills and learn how to prove our thinking. This is important because it makes us aware of our thoughts. And really, if we're more aware of our thoughts, we're really more intelligent. We're able to express our ideas more clearly, and we're able to articulate our opinions and get our point across. This is exactly what type of thinking lawyers use, and detectives, and crime scene investigators. They can't just say that somebody committed the crime because they look like they did. They have to go through a series of logical thinking where they provide evidence, they prove that someone did it. And I was watching Law and Order the other day and created an example proof. You have two columns, statements and reasons. And so in statements you say, okay, Jack's family was kidnapped. Well, how do we know that? Or how did they know that? They knew that because it was reported in a 911 call. Then they found out that he was involved in drugs. How do you know that? What's the reason? The reason is people testified against him and told that. And then they found out he owed money. They found that out through bank statements. So on and so forth. They go through figuring things out and providing the reason for it, and then they reach a conclusion. In which something about a business guy and a mafia and all kinds of things. So it was an interesting episode in which they found out who the criminal was. Now, we're not looking for criminals, we're looking for X. X is our criminal, basically. X is our criminal. We're looking to figure out what X is, and we need to provide reasons. And so looking at this one is pretty simple. And most of you now should be able to do this algebra problem pretty easily. We would subtract 5x from both sides. And we'd be left with 3x plus 3 is equal to 99. So what we're saying now is that 3x plus 3 is 99. We know that because we subtracted 5x from both sides. And we're allowed to do that because what you do to one side of the equal sign, you do to the other. We call that the property of equality. If two things are equal, you can add whatever you want to both sides, or subtract whatever you want from both sides. It doesn't matter. Let me try to move the paper over. Okay, then we would subtract 3. And I'm kind of just trying to show my work small so I don't take up the blanks. But when we subtract 3 from both sides, we end up at 3x equals 96. Again, we know that 3x equals 96 because we subtracted 3 from both sides, and we call that the property of equality. Okay, and lastly, we're going to divide everything by 3, and we end up at the x being 32. And again, you saw here we subtracted from both sides, here we subtracted from both sides, here we divided from both sides. None of that matters. All that matters is that we're doing what we're doing to one side, we're doing to the other, and we call that the property of equality. Property of equality. Okay, looking at the second one. Here we got a bunch of stuff on the same side. And so the first thing we need is to get it all together. We need to combine like terms. 6x and 8x, we can just combine them since they're on the same side of the equal sign and get 14x. 7 and 12, we'll make that 19, equals 47. Okay, we know that this is still a true statement because we just combine like terms, and we're allowed to do that. We combine like terms. Okay, you could abbreviate that CLT, that's fine. And then you need to come in and subtract 19 from both sides. And so you do that, these cancel, and 47 minus 19 is going to be 28. Again, we're doing something to both sides. That's the property of equality. And then divide both sides by 14. And again, property of equality. Property of equality shows up a lot. Moving on to the third example, we're going to distribute Take that negative 3 and times it by everything in the parentheses. So we know that this is a true statement because we just distributed. That's just called the distributive property. Okay, and then from there, this gets pretty repetitive. For the most part, it's just going to be a bunch of properties of equalities. Now, this isn't always going to be the case. As things get harder throughout the year, you'll see less and less of these, but we're starting out simple, and so you see property of equality a lot. Divide by negative 9, and again, we know that x is 5 because we divided both sides by negative 9, and there's our answer. So here we found out that x is 32, got the proof. X is 2, got the proof. X is 5, we have the proof. Okay, the cool thing is we know we're right. As you're doing your work, you can check yourself and see, okay, I know that I'm right, and I got the proof. I have the evidence. And these are the common properties that you're going to see in these algebra proofs. The distributive property is just when you're taking a number and timesing it to both sides, or all things inside the parentheses. It doesn't have to be 2. There could be 3 things in here. It could be 4. It doesn't matter. We're just distributing to each member inside the parentheses. Property of equality is when you do something to both sides. It doesn't matter. If 2 plus 3 equals 5, we could come in here and add a horse. As long as we do it to both sides, it's okay. And that's a hideous looking horse. But we can do whatever we want as long as we do it to both sides. And then lastly, combining like terms is when you got a bunch of stuff on the same side. It doesn't matter how many, but they're all on the same side, and so we need to clean up this mess and combine the like terms.